Engineering graphics is the language used to convey information about an object necessary for it to be constructed. All engineering disciplines use graphics to bring an idea into reality. Here is a list of some of the engineering disciplines: mechanical, architectural, civil, electrical, and mechatronics is the newest discipline. Notice that most of these disciplines do overlap. You can see that in mechanical there's hydraulics. Also, architectural uses hydraulics. Civil has some structural components, and architectural has structural. Engineering standards have developed over the years to make communication of drawing intent clear. This allows engineers to speak the same language, provides consistent drawing practices, which causes drawings to be produced more efficiently and ups productivity. Standards are governed by several organizations. We will be concerned mostly with the 4 that you see here on the screen. The National CAD Standards deals with drafting conventions such as layers and symbols. ASME governs things like dimensions and tolerances, while ANSI governs paper sizes, and ISO is the metric equivalent to ANSI. Most companies have adopted standards to be more productive. You see a list here, such as naming conventions, drawing templates, units, the layout of views, borders, title blocks, layers, symbols, text, and the way that the drawing is printed. There are some definitions that are important for you to be aware of. Engineering drawings completely define an object by size, material, and construction procedure. 2D drawings display objects in a flat format and include dimensions, notes, symbols, and are usually referred to as multi-view drawings. 3D models recently have become referred to as digital twins because they are an exact representation of an object and can be used for analysis or to simulate its function in an assembly. The user interface is the way that we interact with the software program, and it includes things like the screen, keyboard, and a mouse. A command is the instruction that we use to tell the software to complete a specific task. An option is a choice associated with the command or an alternative function of that command. Templates are files that define the specific settings needed for a certain drawing type. A feature is a defined mechanical shape of a part. You also have work features, which are axes, planes, and points. It's very important that you are familiar with geometry, so here are some more definitions. Perpendicular lines are 90 degrees to each other and described as orthogonal. You will become very familiar with that term in AutoCAD. You have a drafting tool referred to as ortho. Parallel lines never intersect and they're on the same plane. Tangent lines touch only one point on a curve. Circles will be used quite frequently. The center is a point that's equal distance from any point on the edge of the circle. A radius is the distance from the center to any point on the circle. And the diameter is the distance of a line that goes through the center of the circle and touches each edge. Arcs are a portion of a circle's circumference, and the circumference is the distance that goes completely around the circle. Circumscribed is the largest circle that can be drawn around an object, where inscribed is the smallest circle that can be drawn inside an object. Angles are another important part of designing in CAD. You have acute, which is less than 90 degrees. A right angle, of course, is 90 degrees. Obtuse, between 90 and 180. A straight line is considered 180 degrees, sometimes referred to as 0 degrees. Reflex is between 180 and full rotation, which is 360 degrees. Congruent angles are exactly equal in size and shape. Vertical angles are congruent, and vertical angles are defined by two lines that intersect, and they are the angles opposite one another. Polygons are made up of straight lines that connect. Area is the space that's measured inside a two-dimensional object. Perimeter is the distance around the outside of any object, and volume is the space that's inside of a solid.